So hello everybody, welcome to the OAI workshop in Porto, also on my behalf. Those who don't know me, my name is Robert Schmidt. I work for the OpenAirInterface Software Alliance as a run team lead, and I'm the maintainer of the OpenAirInterface 5G repository. But okay, I'm not here talking about myself. I'm basically here to now moderate this first of the two blocks that we have this afternoon. The first one I think will be quite interesting with a couple of topics on ARN, but not only. And yes, our first speaker who can also already come to the front is Martin Kasparick, who works for airpuls, which is a company in Germany that develops 5G solutions that are based on OpenAirInterface with a particular focus, I think, on latency critical communications, time-sensitive networks. And yes, he will talk exactly about that. So the topic is enabling TSN and industrial traffic with OpenAirInterface. So and I think that we can start.
Okay. Yes. Okay, thanks, Robert, for the introduction. So I almost have the feeling I need to apologize. This is probably the only talk in this two-day workshop where you will not hear the words AI and also not the words 6G. So sorry for this. No, I'm talking about a topic which is actually quite old and has been around even in the beginning of 5G as a promise, how to enable wireless industrial use cases with wireless technology, let's say. Before I start with this topic, I took the liberty to include two slides about us as airpuls, because maybe many of you don't know actually who we are. So what we're doing, I mean, we started 5 years ago as a spin-off of the Fraunhofer Institute and the TU Berlin in Berlin, Germany. And we see us as a kind of system integrator for Open RAN and open source private networks. So especially when people come to us, they want to have not, let's say, off-the-shelf. They don't come with off-the-shelf use cases, and they typically don't have off-the-shelf networks that they would like to realize, but we do a lot of customization, a lot for R&D and prototyping purposes in academia, but also in industry. But let's say outside of the lab. So that's what we are doing. So we are building actual deployments, and we are using, as Robert said, the OpenAirInterface stack also a lot for this. What we also do is, of course, we provide a lot of support for customization and also own developments when we have deployed this kind of networks. So what do I mean with the customization? So I brought some examples of networks that we are building. I mean, one example is this kind of portable networks. So in the first thing you see, let's say a network we built for a customer who are in agriculture. So he wanted to have portable base stations, each with up to 1 kilometer of range. He can put on the field, do the testing. It was a vineyard in Koblenz, Germany, and then can take away with him on a trailer of a truck. Then we built, let's say, test beds not only for communication. So we have here also for other use cases. The second example is a network which we have been recently building in Hamburg, Germany. There's an old harbor building which they, let's say, converted into an office and research space, and they would like to have a test bed here for actually positioning, so they don't have anything to do with communication. They're just doing research on 5G-based positioning and other positioning examples. And also customers are interested in security testing. So the third example I brought with me is a network we built recently for the German National Authority for Cybersecurity, where we built actually two networks because they were also interested in roaming topics, which are fully, let's say, full-blown ORA networks, including SMO, including RIG. And I have to say, from a system integrator perspective, this is really a nightmare if you have to build something like this. So, but I think, as I said, customization is, let's say, maybe our main claim in the software-based networks which ORAN, let's say, bring is the enabler for this. But now, what I would like to talk actually about is the industrial wireless and wireless industrial connectivity. This kind of slide I could have easily shown 10 years ago. I mean, it was shown in the beginning of 5G. This same kind of motivation slides, they still fit because all these kind of promises still have not been really held. So what we need in industry is actually deterministic communication. We need to bound latency, we need to bound jitter in order to bring the many industrial use cases and introduce wireless connectivity into the industrial use cases. So examples are there's a lot of demand for cable replacement, for closed loop control over wireless networks. Coordinating, cooperating robots are more recent examples. Safety, functionality, real-time vision. So this is all the use cases where you need actually kind of deterministic wireless communication or deterministic communication at all. And how is the situation in industry look like now? It's, oh sorry, there's not a pointer here, I don't know. Anyway, so on the top left you see how the situation is right now. So I mean, of course, industrial applications, they talk industrial protocols, and you see that there's a big bunch of protocols at the moment: Profinet, EtherCAT, ProfiSafe, a lot of industrial protocols, and yeah, this kind of zoo. There was an attempt to unify this by introducing this TSN, the time-sensitive networking, as a set of IEEE standards, which let's say bring mechanisms for synchronization, for reliability, for latency, for resource management. All these kind of topics is really a big set of standards. It itself has been not, let's say, there was not a major breakthrough yet, but still, I mean, there's a big, still a big, let's say, interest in this kind of developments, and also even if you're talking about the left side of the picture, about this, let's say, legacy industrial protocols, introducing them into in wireless, or introducing wireless networks into these protocols is a really big challenge when it comes to, because of the strict requirements, essentially. Now, if we do try to integrate now 5G into a system like this, then you get a picture which looks more or less like the architecture picture I've drawn here. So essentially, the 5G network, the wireless network, needs to act as more or less a transparent bridge into a much bigger network. This is, let's say, the challenge. And it's not only about, let's say, the user plane data. You see that, of course, the 5G network has a user plane and a control plane, but also the TSN network around it has user plane and a control plane. There are translator functionalities which need to synchronize the timings and the schedulings in the TSN bridge, in the 5G system, and in the outside TSN network. So a bunch of devices which are controlled. And I think it's still, let's say, a big research topic. At least I know in Germany there's a big community still working on these kind of topics to realize this use cases. So I mean, what we essentially need is, as I mentioned before, we need to have we need to get rid of varying latency, yeah, because you have these translators. The network needs to tell the controllers what it can support. You cannot, if you have, let's say, a big variance in the latency, there's no way to have an end-to-end scheduling throughout the whole network. So this is a major requirement. RAN and core must support TSN. There's a lot of functionality which needs to be there. One thing is the Ethernet PDU, 5G LAN, so we need to have native layer 2 connectivity through the network because TSN traffic is layer 2. We need synchronization in the network. We need, of course, low latency quality of service, yeah, because I mean, this is clear that even in congested networks, we need to have the QoS for the critical streams and so on. And yeah, so there's some mechanisms. Some of them I will just talk about in the next slides a little bit more that are, let's say, required to realize this. At the moment, There are no suitable open test systems available for this. I mean, this is a big problem for the entire, let's say, research community. And of course, one goal, at least that we are working on, is to enable OpenAirInterface as a platform for this kind of research to integrate in this kind of industrial architectures, seamlessly with all the components, with all the translators and control plane and user plane and so on. There are some activities I can highlight that we have been doing in this context. One is the Ethernet PDU that I already mentioned. Many factory networks rely actually on layer 2 protocols, so we need this PDU session of type Ethernet. So Ethernet frames are transported natively through the network, MAC addresses, VLAN tags, priority tagging, everything is preserved. This is what you would like to have. And this allows then the 5G system to appear essentially as a transparent TSN bridge. So this topic, I have to say, there has been a lot of progress recently. I mean, we have been even showing demonstrations. There is something called the XG Alliance for Open Enterprise Networks. We are participating in this alliance. There's a working group on 5G TSN, and this is, for example, one of the demonstrations that we have been showing at the IEEE Wireless Factory Communication System conference from this working group to showcase this functionality. So I think there is some good progress here on this topic. So it has been tested with OpenAirInterface Core, by the way. I think Stefan and his team from Fintech did great work here on this topic, and has been tested with other core networks. So I think from the core network perspective, this is more or less not a big deal. Problem, as with many of these topics, is on the UE side. There are not many commercial UEs which support this functionality. We have been able to test it with a very specific Quectel modem which supports this Ethernet PDU functionality. There are not many around. Qualcomm has promised something for this summer. I'm looking forward to getting something from them. Let's say, but it's also available in OAI UE, for example. I think Robert demonstrated it also already a while ago. So at least for testing, it's there. So I think it's some good progress here. Another big topic is the time synchronization. As I said, TSN requires, let's say, network-wide clock synchronization between all the different instances. And one mechanism in the 5G that we have to realize this kind of synchronization functionality is the SIP9. It allows the 5G actually to act then as a time-aware system. We needed to have this kind of end-to-end scheduling. So it's a broadcast message, essentially, that carries the current timing information from the base station to all the UEs. The G.B here just encodes the time and transmits it, broadcasts it, and the UEs can decode it and synchronize their internal clocks. So far it's so simple. It's very simple features, very easy. It allows the UE to sync with the cell in a much more fine-grained, let's say, accuracy than without it. There is some development work ongoing. So I think we have, for example, a prototype implementation of the SIP9 and OAI that we are currently testing. We are just broadcasting the cell time. I've put the test set up here. There's some commercial UEs. In this case, it's a Telet modem that we are using, which supports the SIP9 functionality for testing. The only problem is here, which is not so easy, is how to get actually the time out of the UE. Because what you would like to do, of course, you would like to use this time information to synchronize a translator function, and with this, some devices which are behind the UE. So what you actually need is to get a hardware output, a PPS signal, something like this from your UE. Actually, this is also something that Qualcomm has promised for this year, and I'm also waiting for this one. Until then, we are, let's say, living with this kind of hacks. So it's like a Raspberry Pi hat where we built, we integrated this Telet modem, and then you can solder a certain pin to the M2 module, and you can get a PPS signal out if you have the right firmware on this Telet modem. So there are some things you can do, but of course it would be nice to to have some more development on the hardware side as well. But we'll see. Yeah, so this is some ongoing work. Also, what we do in the XGLO mainly, and I think it's a very important stepstone for many of the industrial applications, this kind of time synchronization topics. Another topic is more related to the quality of service. So I think there is one thing that we would like to look at more is topic of scheduling and quality of service, especially also in the uplink. So there's this configured grant topic here. So it means scheduling essentially is a major source of latency variation in the network, and especially if you're not in a single UE network, of course. And of course, 3GPP has mechanisms to deal with this. On the uplink, it's, for example, the configured grant. So the base station essentially pre-configures some periodic transmission, and the UE knows exactly when to transmit without having to, let's say, go through this kind of request grant loop all the time, let's say. So this is essentially required, very useful for bound latency and jitter in the uplink. This is especially also if you transmit not even TSN but also Profinet, this kind of traffic. If you would like to transmit over wireless, it cannot live with jitter. So this is something which is really a requirement here. And yeah, so this configured grant, therefore, we see it as an important enabler. We would like to work more in the future on this. There is a project funded by research project funded by Germany and Finland with German and Finnish partners. We are going to work on this topic in the next, let's say, 2.5 years to bring this forward. Probably there's two types of this configured grant. We will start with a simpler case, this type 1. Also here we are interested in testing with commercial UEs, as we are usually in our test beds. And okay, I can make it. So at least here the UE side is not the big problem, but the base station side, and I think here, yeah, I would also like to advertise a little bit this kind of topics, quality of service in the community. So if there are people interested in working on this, this would be, I think, a nice opportunity for bring private network use cases forward. Okay, this is actually already the topics I would like to mention. I didn't mention other things. There are more things like the slicing, the scheduling with preemption, and let's say a prioritization. There's more that we need actually, but these are, let's say, particular examples of features that we are currently working on. So in summary, I mean, let's say the deterministic wireless communication remains quite challenging, but it will be, in my opinion, critical success factor for private networks. So if the private cellular networks cannot fulfill the promises that they made to the verticals and especially to the industry, then it will be difficult, yeah, for them to compete against Wi-Fi and other technologies. And we see, at least in Germany, the high need for the testbed infrastructures that allow this kind of testing of this integration of 5G into broader industrial architectures. And we see that missing features are being developed step by step, but we think there could be also a little bit more traction here, and that's why I would like to also advertise. So if you're interested in collaborating on this kind of use cases and QS topics, then feel free to approach me. Okay, that's my overview. Thanks a lot for your attention.
Are there questions? We have time for one quick question. Well, then maybe let me ask one brief question. I mean, you showed now various enablers Once, let's assume all of this would be done, is this already enough, or is there still a standardization gap? Is there things that are in that regard in 6G that would be critical, crucial in some way?
I mean, I think it's not, I mean, the standardization goes on. I mean, this is, let's say, my view is very basic. I left out a lot of things. I mean, there are things like Stefan is working on the core network. There's the application functions which bring the control plane of the TSN together with the control plane of the 5G network. There is now new standards up from release 17. They standardized that the grandmaster clock can be on the UE side and not on the base station side. So there are definitely some developments and it's going on, but I don't see a big standardization gap. I think the biggest gap here is that these kind of use cases are not in the main interest of the big network vendors, and also especially not on the big UE vendors. And features which are actually already in the standard for a long time are simply not being actually put on the market very fast, and this is a very big problem for these use cases. And I think when we have at least a way to demonstrate and to showcase the benefits of these technologies, then I think we will make a step forward, let's say.
Okay, thank you, Martin.
You're welcome.